So welcome everybody to the App Builders Zurich Meetup. It's been a while since the last event. And the reason was I was kind of like overloaded organizing other stuff. And in the meantime, by the way, my name is John Reardon. I work for Swisscom. I'm a product manager or business development manager there. But I've also taken over managing a group of app developers, web apps. And so I thought it was a good excuse to start doing the App Builder Zurich event again, because we're going to have lots of apps coming up. So today we're going to be doing an introduction. I've got very interested in augmented reality. We're going to have a presentation by mostly Scout24 employees. They used to be all Scout24 employees, but they're not anymore. So they're actually sponsoring the drinks. And so our three speakers this evening, I'll let them introduce themselves. They're going to talk about their work with ARKit and give a demonstration, I believe.
Yep.
And follow that, we're going to have questions and answers. And follow that, we're going to get drunk. So, how of you guys?
Yep, you can start.
Yeah, I am the last one of the list, Terence. Okay. Voila, I'm back. I'm the last one of the list, Terence. I am 29 years old. I work at the SBB as an iOS developer. And yeah, that's all from my side.
I am in the middle of the list. My name is Jan Böller. I'm working for Scout24 and I'm now developing since 7 years iOS apps for different companies, and since 1 year I'm by Scout24.
Yeah. So my name is Adrian. I am Spanish, and I'm now about 8 years in Switzerland. I joined the Scout about a little bit more than a year ago. Joined the iOS development team for the ImoScout platform. Hey people, thanks for coming and joining us tonight to talk about ARKit. So ARKit is a village in Kyrgyzstan, and oh wait, maybe that's not the ARKit you were thinking about? Well, that's what I found in Wikipedia, so you must be right. Okay, no. We came to talk about ARKit, of course, the augmented reality package from Apple, available since iOS 11 in capable devices, which is mostly your new iPhones and iPads. And the topic today is to tell about our experiment that we had about October last year. So we took, as the three of us were in Scout24, we took 3 days for us to do an internal hackathon on the topic of augmented reality. And the use case or the challenge was, can we use and leverage this technology to provide good enough measures of a room? So the surface of a room. So that was a challenge. We had no previous experience with augmented reality, and we're going to tell about what we learned in that experience. As John mentioned, maybe there's not need to dwell on this. This is sponsored by Scout24. Scout24 have these 3 major platforms, which are all marketplaces for vehicles, real estate, and classified ads. And there's a link that you can follow if you're interested in to knowing the open positions. We just covered the position from Terence, so that's not open anymore. And thanks, Jan, for organizing and putting together this group. It's really exciting for us to be here. And it's been a while, like John said, since the last meetup, so it's a perfect excuse to get together, discuss about these things, and have a couple of drinks together. So, without further ado, I give it to Terence.
I also want to thank someone. So thank you, Adrian, that you organized for our side and that you had the idea to make an event for tonight. Now, the team that worked on this mini project is here. So we have Adrian, the Spanish accent. Then we have the Swiss-German accent of Jan, and myself with my Italian accent. At the end of the presentation, you can rate who has the best or the worst accent. As we said, we are all iOS developers, and at the time when we did the project, we were working at Scout. Now, what we did. The idea is that when Apple presented in June their ARKit, we wanted to do some experiments or look what is possible with ARKit, play a bit with that technology. And so we came to the idea to make like a working prototype, not just do some experiments, but really have something that works, that you can present, that you can really use, because it's not the same when you do just some small experiments and nothing works. After that you tap on the button, it's not the same as when you have really something that more or less works, like a mini product. And the last objective was to have fun, because if we don't have fun, it's, the motivation is not there. Why do we wanted to do that? One of the reasons is, it's probably not the first reason, but officially is the first reason, is to try to solve a real life problem, because it's fun to make experiments and use technology, but if you don't solve problems and nobody uses it, it's not necessary. Another reason was to educate ourselves, so learn something new, and also to learn a new paradigm, because so augmented reality, it's like kind of new paradigm. It's 3D, but in the real world, and so there are some new aspects, like for example, how do you do the UI of the app of a real augmented reality app? It's not the same as a website or a 2D apps. And so this project was done during 3 days in October. So 3 days is not a lot, but when you focus during 3 days on something, and you, especially if you don't have meetings and you don't answer your emails and you don't, you close the chat, you can do something when you focus. This is the reason why I wrote that we were isolated from the rest of the world. We were working there. It's a co-working space in Bern, just for us during those 3 days. Now, let's talk a bit about ARKit. Probably most of you know already what's ARKit, what you can do. Maybe you did some experiments, but there are maybe also some people that never really checked what you can do with that. And I will quickly explain what is ARKit. So if you don't know what's that, you will learn probably something. If you already know, it's like a small repetition. So ARKit, it's an augmented reality technology presented by Apple last year in June. Augmented reality means, to be very short, that you can put virtual objects in the real space. And the implementation of Apple works on the iPhone and on the iPad for the moment. They are probably planning something else, like, for example, glasses, I can imagine. But for the moment, works on the phones and on the iPads. And it used the camera and the sensor of the devices to recognize the surroundings. For example, recognize the floor. Here there is a small video that was shown at the conference of Apple last year. You see there is the real world, the table and the people. You see the iPad, which is the platform where ARKit runs, and you see also the the virtual objects on that. ARKit works on practically all modern iOS devices. If you have iOS 11, it means it's a big potential, because there are potentially already probably 1 billion of devices that can run that. So it's interesting. And one aspect that was useful for our experiment is that it's quite precise in distances. We will show later exactly what I mean for that. Another aspect is that this technology can recognize quite well planes, like for example the table. It can recognize the plane of the table, the surface, or the floor. And it can also recognize that there are some objects in the space. There is a video that shows that well. So here there is a session. You can see whenever a plane is recognized, there is a blue plane which is shown. And whenever an object is recognized, which is not flat, it shows some yellow points. They called feature points. I don't know if you see. The image is not very well, but... And it recognized that quasi real time, we could say. It's quite fast on the recognition. It depends on the light. It depends on a lot of aspects. This is more or less what we can do. Now, okay, this is interesting, but what do we want to do with that? Which problem do we want to solve? As Immo Scout is part of the Scout group, we imagine something that could be interesting for them, which is one person that wants to sell his house. So, quite simple. This person needs maybe the floor plan of the house. It's not something that I don't have the ones of the house where I live, for example. Oh, it's not my house, but... And this person wants to have the measures of every room of the house where he lives. And yeah, you can measure manually, which is not very funny. Or you can buy some laser devices. I don't know how much they cost. Or maybe you can... Well, this is the problem that we would like to solve with our solution. Or this is the vision. The final solution would be something like that. And the solution come now.
So we're going to open our prototype app, which is called Area. And that's the icon that Jan made. So the first thing we do is we start the app and we point at the floor. There was a split second where it was a loading plane moment, and now we place a polygon on the plane on the floor. So as we move around, and what we are looking here at the screen is what we were seeing through the camera. As we move around, we can see that that rectangle, that polygon, is staying where it is. So what's going on in the background is that it's ARKit is calculating the movement and the distances. We'll go more about that in a minute. But it feels really seamless, the experience. So as we move away or closer, so that object behaves like we would expect. And that's the power of the augmented reality experience. So okay, we place this sample polygon on the floor, and now we have the challenge of how do we deal with the interaction. So like Terence was explaining before, this is quite a departure from the way we are used to make our apps. So we are used to have an interface with buttons, and the screen is mostly covered with either content or controls. But in the human interface guidelines, it is said that we should be as unobtrusive as possible. So controls should be intuitive and not clogging with buttons the UI. So in this particular case, maybe the easiest thing to think about is to take these points and drag them around. So just place the finger, move my finger, and the point is updated. So the power of this is that as I move the point doesn't move just in any arbitrary way. It moves in a way that resembles the movement of an object over the floor. So as I move closer, it feels like the point is really on the floor. And this is quite interesting because it's giving us some information about the real world that we can manage into our virtual world. Coming into the prototype itself and the use case we had, we used two kinds of labels. So on the sides of the polygons, we have the length of the side, and that's living in the virtual space. So it gets bigger when we get closer, it gets smaller when we walk away, as if they were really hanging there in a space. The other part we have is this label here, which is a normal UI label from UIKit, and that stays always in the same point, and that matches our expectation of such an app where we move around and the polygon is being, refreshed and updated towards the real position of the device camera, but I'm always seeing the surface here on the screen. Okay, so let's try and make this a little bit more realistic, and let's measure more or less this area we are standing on. So I can walk around the room and place the points where I need them. Right as if I was measuring a room and I would be walking around, knee on the floor, extending my measuring tape. Now, let's say that I have a little corner here and 2 points are not enough. So we added another gesture, which is double tap, and we can add more vertices to our polygon. And like that, we can adjust exactly to the shape of the room. If we don't need those points, we can get rid of them, which is with that button right there on the navigation bar. So that was an example of one button that we do show, but other interactions are directly embedded into the AR experience.
Maybe I say something
Sure.
obvious, but the video is laggy, not on the phone, but it's only the connection between the two devices. Just
correct. Okay, so that's the first taste of the prototype. So we're going to cover 3 main areas of technical discussion. I will do the first. Oops, that's this way. About the main data structures and the data types of the SDK. Then Jan will cover working with planes, some practical aspects, and then Terence will talk about the math. Okay, so now that we've seen the demo, what is ARKit really offering us? And we have 4 key aspects. One is device motion tracking. As we move, the iPhone is registering how it's moving in a space with the gyroscope and such. There's camera scene capture. We're using the camera of the device to capture the image of our surroundings. There is advanced scene processing, where ARKit is processing what is coming through the feed of the camera and trying to recognize low-level features, and from those low-level features, higher-level features. And then we have some display conveniences, like the vertices and sides that we projected in our polygon. And all this together is basically ARKit, and it's what ARKit is providing as developers to create our experiences on top of. So we were talking about these display conveniences. There are 3 content technologies that are available to us to display these elements in the virtual world. The first one is SceneKit for basic use cases, and the one we used. And you already saw we could plant a vertex in the polygon and move around in a space, and the polygon would refresh in real time to create the illusion that is really there. Then we have a SpriteKit for 3D images, and I don't find that particularly interesting. If you remember your days of playing Doom, you maybe remember that you had these enemies that were just sprites, and you would move in this pseudo 3D space, and the enemy would give you the same sprite to you until you cross a certain threshold point, and then you would get another sprite. So actually the engine is replacing sprites to create the illusion that you're really going around the object, although the object is really flat. So that's the kind of experience we could get with a SpriteKit. Yeah. Or for more professional or high-end cases like the video we saw from WWDC, we will use custom renderers like the Unity and Unreal rendering engines. And at this point, it looks like game programming. It feels like game programming. So maybe developers are going to feel immediately at home with ARKit, whereas for us who come for the app programming, it's quite a departure. So it's quite interesting and challenging in that regard. So let's look at some code. So this is the minimal setup to start an AR app. So we have a view controller, and we conform to this AR scene view delegate. And we will look at the delegate methods in a moment. Then we have a scene view that we connect through an outlet to the view controller to take the whole screen like we had here. We had the whole screen except for the navigation controller. Typically in view.load, we would create the session and the scene and set ourselves as the delegate. Then in view will appear, we would create the tracking configuration, the world tracking configuration object as to give us a configuration. Then we need to say what are the characteristics of that configuration. Like in this case, we are interested into the plane detection. We want to detect the floor. So that's not enabled by default because it's computationally expensive. So we have to say, hey, I want to recognize horizontal planes. And at the time we did this, and that was the only kind of plane that was available to us. We'll talk about that more later. And essentially, we just pass that configuration to the session, and we're good to go. That's all you need to have a video feed, which is applying ARKit to your surroundings. And these are the delegate methods, because at this point, you basically start the live feed of video, and you wait. You wait until ARKit tells you that you've got stuff to work on. And you wait until you're called on one of these methods. So for us, it was particularly important. This method did add, which is where ARKit tells us that it found a new plane. So let's talk a little bit more about these two main data structures, which are the SCN node and the AR anchor. So SCN node is the structural element in the hierarchy with which we create our virtual world. So a scene node is to scene kit what UI view is to UI kit. It's the basic element that you connect in the hierarchy to create your UI. So in the same way that we have add subviews in a view for UI kit, we have add child node in a node in SN kit, and that you can create your virtual UI. The AR anchor instead is a real-world position and orientation where we can place virtual objects in the scene. So AR, the prefix AR relates to stuff that belongs to the world, to the 3D world, and the prefix scene is a stuff that belongs to the content that we project on that environment. Essentially that. So we render those nodes onto the anchor positions to create that illusion, like we were rendering the vertices on the floor anchor, the plane anchor. So we'll go now over the basic process of detecting that plane, that floor. So first, ARKit detects feature points, the yellow points that we saw previously in the video. And as you move around, ARKit will learn about your environment and will register those feature points. And those are low-level features. At this point, there's not that much that you can do, although you do get called by when these points are found. Then these points are assembled somehow, and that's the magic of ARKit. And at some point, ARKit decides, I have enough points to tell you that there is a plane here. There is an AR anchor plane, a plane anchor. And that's a higher level feature, and that's the one we were looking for when we ran the prototype app. We get the AR plane anchor in this delegate method that did add. And that's when we can start doing our logic, in this particular case, projecting the polygon on the floor. Let's have some practical considerations or experiences related to the plane detection, because that's where some things are not so obvious. The first one is that plane detection is slow and depends on environmental factors. So let's go back to the demo now. So let's start the app again. And let's focus on this particular phase when we're loading the plane. So That was the polygon. That wasn't too bad. But sometimes it takes longer. We have a hidden gesture, which is shake the device to reset the session. And now we move again. And that's the polygon. And the tracking seems to be a little bit off. It kind of shifts a bit. Maybe we didn't have the right gesture for resetting the session. We were doing some tries before. And maybe it is the shaking that is making it difficult for ARKit to find the planes. But essentially, we are stuck until we get the plane. And now it's working really good. It's working really fast. So one thing we did when we were doing this experiment is that we took a carpet with us. Because a carpet would give us more feature points. There's more contrast. Now, this floor is quite good for contrast because of the different coloring and the shades. So the more contrast your surface has, the easier it is, because you have more feature points, and the more feature points you have, at some point, then ARKit figures out there is a plane. But sometimes when we were developing and the floor on the room we were at was not that good in contrast, we would wait there for 30 seconds, 40 seconds, waiting for this polygon to appear. And that was very frustrating. And it was also not very consistent. Like sometimes it would be fast and we wouldn't know why, and sometimes it would be very slow. And this is quite critical because we're basically stuck until we get the AR plane anchor, because that's when we start with our logic. And it's interesting to see how some developers are dealing with that. One of my favorite examples is that from Oscar Falmer in the Tweet Reality app, and I'm just going to show you what it looks like. This is a augmented reality app for your Twitter feed. And he has this idea of a hand that moves around. Oh, and it was so fast already. Let's try that again. It loads, and it has a hand, and you move around, and then it's look up. So you look up, and it opens, and you see your Twitter feed. There you go. Maybe we have one from Acosma there. Can't find it right now. Never mind. So that was kind of a little gamification element. This hand moving came to invite the user to kind of follow the movement. It's kind of tricking the user or educating the user into getting more feature points. And that's quite interesting to me to see how that works, because it's a very critical moment for the user experience. Because as I said, before we have the plane, we can't do anything. And it can feel very frustrating for the user if you're standing there looking at the loading indicator and you don't know if the app is broken, if you don't know how to use it, if you're not knowing what to do next. Some other authors have their own heuristics. So here's what they do, and I'll show you as well. They don't wait for the plane to be ready. They just go with the feature points, and they just try and make their own heuristics out of those feature points. Let's see how that looks like with an example. So we have this app, which is also a ruler app. So let's just start here, which is over here. We see lots of feature points on the Mac keyboard. And let's measure the side of it. And it's 11 centimeters. And I move around. And it looks to be right on place. So that's not too bad. Did you see that, by the way? Or am I in the way? Sorry, I was in the way. So if I go here, you see that's the line that I plotted. So let's go now on the floor. And I put, let's measure the diameter here. Okay, around there. That was not too bad. That's actually pretty good. Stays in place because there's lots of feature points on this carpet. Let's go on a point like this and try and measure that.
Maybe on the table.
That's also quite good. if I go on the table, it's actually not. You see, it's losing track of that measure. How about here in the shade? Okay. And that's floating in midair. Let's measure the cable now. And it's also a little bit floating in midair. And it's looking better now that in our experiments. The point being that you can go brave and do your calculation out of the feature points. If you have enough feature points, then your results are okay. But we had the experience of the point being floating in midair because the plane couldn't be recognized. So for us, that was unacceptable. So we have to wait for the plane to be detected, and yeah, that's a little bit of a pain point. One last point is that, like I said, plane detection consumes resources. So if you don't need it, you can disable in the configuration parameter we saw before. And one thing we noticed is that after a while of moving around, the device gets warm in your hand. Like it's really processing, it's really making use of the processors. And that can also explain why you cannot run it in older devices like an iPhone 6, because the chip is not powerful enough.
So, yeah, this is a screenshot from our plane detection, and it's in the office. And when you see the size of the plane, it's a little bit slow, or it's not really big. So, yeah, it's a little bit of a problem when I will tracking some points on it. And I need some object in the virtual world to get a hit point for tracking the point there. So I need a virtual object in the room. So the easiest solution we found out is make it just bigger than the detection size. So we added a 1 kilometer big plane as a second plane, so we see no boss. I will explain it a little bit more with my draws. So that's the iPhone. When we're detecting a plane like this size from the ARKit, so that's what we get. And then we just added our own tracking plane. So there we can get every touch point. So that works like we touching on the phone, then it make a hit test, and we found the point on the tracking plane. And so we can put there the point, and when we move it, when the animation starts, yes. So we can move the points on our floor, and we have also the possibility to measure the whole floor and not just the recognized part. So the tap location is just 1 point. So when we tap, we get 1 XY position on the screen. And yeah, when we see the small point there, it can be hard to tap this. My fingers are not so small that I have this precision for that. So we have the minigun solution. That was, in the 3-day we implemented in this way. So we don't see the circle, but here is a circle. It's a little bit too light. And when we tap, then we get this point back. And our minigun solution was just searching. And when we found some point there, then we know the object, and then we can starting to track. But that was a really bad idea. After the hackathon, we are a little bit rethinking about that. And the easier way to do this problem, and that's also what we learned. That's what we're meaning with when you're coming from game development, that will be maybe basics. But when you have the daily work with 2D, maybe the 3D is the layer of the views. and you are not, it's not your daily work, then yeah, do it maybe on the first time wrong. And the second solution was we tap on the screen, we take every point we have to track and make a projection to the screen, so we know the XY position on the screen now. And so we can just easy measure the distance of the vertex. So, and then when it's close enough, then we say, yeah, you hit it. And this will be much more it's a much more better solution, because it's not so much calculation, it's not searching something. And maybe when we see the points in the minigun solution before, that you can easily miss the point when it's really small. So this is the better solution. But yeah, on the first seconds in the hackathon, we don't get the right one.
Now, when we work with in the 3D world, whenever you want to place an object in this 3D world, with ARKit it's relatively simple. Let's say I want to put an object here in front of me. I have to create an SEN node if I use SceneKit, which has 3 coordinates, x, y, z. Let's say I put my object here, and now when I move, let's say I'm using my device, I put my object here. When I move, my object stays there. I don't have to recalculate everything. This is done by the system. This is why it's so simple to plot some virtual objects in the plane. So let's explain a bit more how we did for the measurement between the distance of the objects. What we did here is that we put an object here on the floor, another object here, and those objects have their x, y, z coordinates. And in order to get the distance between them, so this is the distance, 1.14 m, we just need some math. The normal math that we learned at school. It's not something specific for iOS or for ARKit. So let's get this distance. How we get this distance? There is a formula, which is just the geometrical way to get the distance between 2 points in the 3D space. The same is whenever we want to get the area of our polygon. It's exactly the same way. The only difference is that for the polygon we don't have just 2 points, but we have a lot of points. So we need also a mathematical formula for that, which is very simple, just that. No, actually, this was our reaction when we saw this formula. But we were lucky because a Chinese guy developed in Swift this formula. So we could just take the code and use it. But also to say, in that case, that it's only a normal mathematical formula necessary to do this calculation that we would do real time in our app. Another important thing that was helping us a lot during our implementation was unit test. Maybe you ask yourself why we write unit test for a project that it's an experiment during 3 days, but actually it was helping us quite a lot, because every time that we wanted to install the app in the device with that famous cable, we lost time, because there is building time, okay, it's not such a big application, so it was not so much. But especially then, we lose time for waiting that ARKit finds the plane. And there was another disadvantage, is that at least at that time, it was impossible to use breakpoints. With ARKit, whenever we set a breakpoint, the ARKit session just disappeared. So it's not that easy to develop in those conditions. That's why probably in the meantime was fixed by Apple, but in October was so in all 3 machines that we tried. And so unit test helped us to spare this time and also to avoid this problematic with breakpoints and also with precision, because when we took the famous formula that I showed before, I go back. When we took this formula, I was not very convinced that we were doing the right work. And in order to make sure that we were really doing the right work, we write just a unit test that measure. So actually here we put 4 points with a square of 1 meter by 1 meter, which should have an area of 1 meter. And with that unit test, we can prove that the code that we took, the library that we used, was working correctly without having to really measure 1 meter by 1 meter without precision and then test with the app. Just to say another thing important about unit test is that you can import ARKit and sync it in unit test and it works, which is not always the case with Apple stuff. And yeah, also to test what Jan mentioned before about finding the nearest point was useful to use unit test.
There was also some limitation. We also already talked a little bit about the speed. So we see it in the demo. Sometimes it's not so fast, so we need some user experience in the beginning for like this shaking animation of the phone and stuff like that. We need to thinking about when you use it. Then yeah, the precision is also not every time really good, especially when we go far. So when we starting a ARKit session, there we have the origin point. So when I go 100 meters in this direction, the calculation starting always from this point, and the precision for measuring is not the same than when we are walking around 10 meters from the starting point of the ARKit session, that we also found out. And yeah, when we have some furnitures in the room that, yeah, it's not so easy. Sometimes it's detecting the plane on it or stuff like that, so that can be also a little limitation. And yeah, we want have one feature that we want on the beginning implemented is to detecting the walls automated. So the polygon jumps or snap to the walls. So then you have not to track all this. But then we found out it's not so easy. But with ARKit 1.5, we can now also detecting walls. So when we have, again, 3 days, we will implement this. Hope. Then to the technical aspect. We already heard about it's not so easy for testing what you implemented, because when you use the debugger, it breaks the session, or when you have no wireless build, then you need first build the app, then remove the cable, and then you can start. So with AR, yeah, without cable will helpful, but it's really slow with Wi-Fi build. It was faster to build the app and then put the cable off. So yeah, it's a nice feature to build wireless, but it's not fast enough. And sometimes it was not so easy to sync this problems in 3D. So it was, yeah, we were just measuring a 2D phase, and on the ending, on the first try, it was the feature points we have was not on the same level. Then we started with the plane, and then it was working. And also the problem I described before with the dragging plane detection, it was different things that we have normally not in 2D development in the daily job. A lot of math, so we already heard a lot about it. And also the user interface of 3D, so you have not a menu or a lot of buttons you can place. You have a little bit thinking about abstract, how you can do this, what is intuitive. And then we go to the quality. Yeah, there is some, it depends, because here we was not sure that the light is enough, so we have a little bit problem on trying the demo. So we're positioning the light in the right thing, and then we're adding this red point on the floor to have a contrast and stuff like that. And here we are also on the next depend point. It's really important to have good contrast on the floor. So when you have something really one color like this white tables, then you can really get in problems. And also when you're moving too fast because of the gyro, you have problems with the detection of the phone movements, and that has an impact of the ARKit system. And don't use it in train or in elevator because it has an interesting behavior.
This is when the train accelerates, you will see what happens. Hey, where is my plane? Hey!
And here.
It's the proof that it used the accelerometer.
Before we go into the questions, I would like to show you still about the new ARKit 1.5, which is in beta. And we installed that on a test device. Let me show you. So here is our prototype app in a iOS 11.3 device, which is in beta as of now. And we have now the possibility to find not only horizontal planes like here, but also vertical planes. So the next vertical plane is over there, so hold on while I'll show you. There you go. So now you see here on the big straw advertising that we can now find vertical planes starting with iOS 11.3 and ARKit 1.5. And this is not to showcase the SDK itself, but is that when we started the prototype, we were thinking, what would be the ideal experience for this use case? The ideal experience would be that you start a device and you just go around the room and then it's scanned. You know, ideally ARKit would have figured it out for you immediately. We're not there yet, and we were challenged by the limitations we found. And now this changes everything, because before we could only find a floor and work on the floor, but now we can find the walls. So if we had to start this again, then we could might as well just go with an approach that goes about detecting the walls. And once we have the walls, even just a fraction of the wall, because we can extend it like we did with the drag plane, we can triangulate the area of the room. And that feels a little bit more human-like you can stand up like that and use your phone like a person, and not so much, going like that, like a monkey. So this is just to say that this is far from a mature field. It's evolving really fast, and everybody's waiting for the next big device that will make this a reality, like the glasses or whatever it's going to be. And new features like this can change your approach completely. So that's something to think about, that maybe you invest a lot into a prototype, into an app, and now a new change comes in, and now you're basically obsolete. So it's something to consider. So now we're ready to take your questions.
Where you draw the polygon is quite intuitive after it's explained, but I can imagine for a first-time user it would be quite confusing. Like, did you get a chance to use it, test it? Or?
Right, that's a very good point. We didn't have a designer, and design wasn't a major point of this experience. It was mostly like exclusively a technical hackathon. Most apps do a little bit of an onboarding, like they have labels, and I think it's a little bit like gaming. So when you play a new game, the first levels tend to walk the user or the player through the basic mechanics of the game. So that's how I see it, that we could use a similar approach, but of course that wasn't the focus, but it's a very good point.
If you had like yellow sticky notes, you just put on the floor, and then it would recognize these targets.
Oh.
As an enhancement,
Right. So then, in that case, I would go with a feature point approach. So yeah, that could help, but I don't know if I could be.
well, I mean, more so that you don't not just define feature points, but so that you pre-program so that you put the sticky notes where you want the vertices to be, and it would automatically find vertices for you. I mean, this is also considering, I mean, I didn't know that you had the wall feature, which is very handy actually, and probably would supersede that. But
Yeah, in the ARKit 1.5 now they have a possibility. I've read the release notes, but I couldn't play with it. Now you have the possibility to recognize images on the wall. So the use case, I think, for the example was that you go into a museum, and then you go and find a painting, and then you recognize it's a painting, and then you can get contextual information. So maybe that's coming with the new SDK, but I really don't know more.
I think you can use the machine learning SDK also. With that, you can detecting custom stuff, and you can mixing this with ARKit also. I see also when you YouTube search with this ARKit and Core ML is the name of the SDK, then you find some solution there. They use machine learning for detecting stuff in the real world, and then you can use ARKit to find the position of this thing you will detecting. That will be a possibility when I get.
okay, thank you.
Do you get a description of the feature points? Because actually related to his question, I guess that those anchors are just like vectors in the 3D space, or do you get like a shift descriptor or anything that you can use to maybe, filter out the ones that you want? Could be the sticky notes or by color or whatever.
So the anchor gives you a point and an orientation, and that's what you have to work with. So I think what you're saying is that if you get more contextual information about the kind of texture, maybe something like that?
No, I'm thinking more from the computer vision perspective. So normally these feature points have a matrix descriptor from other frameworks. So is ARKit exposing these feature descriptors so that you can play with them as well?
I don't know about that. Do you guys know?
I was not really sure.
I think that you just receive the point position for the moment. It's just here there is something, there is this position at this position, but nothing more, as I know.
Now with ARKit 1.5, you get geometry, which is a new property, and that gives you a 3D mesh of an object, of a plane, for instance. And so the information that we get continues to be extended, so maybe that helps in the future.
Are you able to get the distance to the object from the device? Because basically, if you can get the surface, I guess you have the notion of how far are you from a certain object, right?
Yes, exactly. We also implemented something that when you track too far, that you don't, when you track the point too far, you don't see the point anymore. So we're measuring the distance, and about, 10 meters, we're stopping the tracking. So that's really easy, possible.
Actually, interesting is that the point of origin is where you start the session. So let's say I start the session here, so that's the origin. So everything else is calculated in regards to this point. And again, with ARKit 1.5, you can change that point. But one experiment we had in the office that we had an open space. Don't you love them? And then we wanted to measure the open space. So that's many meters that you walk. And that what we found is that the precision was not so accurate the more we walk from the origin, the point where you started the app, which is completely strange for the user, because the user is not maybe thinking, where did I start the app? And that actually has an impact in calculating the values of the distances.
How much is the energy consumption in your experience?
So you mean for the battery?
Yes.
So it runs out pretty fast because it gets very, very hot in the hand, and it's really using a lot of CPU power. So one thing we didn't do, because we didn't care at that time, we didn't disable the plane detection. So the whole time we're moving around, ARKit is trying to find planes. So one thing you can do to easily optimize is, once you have the plane you need, stop looking for planes, and that should take away from the CPU consumption. But still, I would think it's a very demanding kind of application.
But you still then always use the first plane you detected, or you always use the first plane?
We just found one.
And then you go for it?
Yeah.
Okay.
Right. One interesting aspect about that is that we had the delegate methods, did add and then did update. So ARKit finds a plane, and if you don't disable it, it keeps refreshing and expanding the plane. The more it recognizes around the plane it had, the more it grows it. And then you get called on the did update delegate method. But then it was a little bit tricky to match it to the previous object, because now the new plane has a different center and a different extent, and it's a new object. So we would need to do some calculation to really relate a new anchor that comes through the did update delegate method with the plane anchor that we had with the did add method.
Sorry, thanks. In the demo which you showed before, maybe it wasn't your video, but it was basically detecting planes on different objects like a couch and on the floor and so forth. But these are multiple plane detections, which, I mean, thinking as sort of building out the app, is that you could stitch all these together until it found a wall, and then you could basically get the area.
We stopped at the first plane, but that's because that's what we did in our logic. But of course, you could keep detecting planes and growing them and merging them. You could do that totally, but we just didn't do it for the prototype.
Okay.
What do you think about detecting inclining or declining planes like roofs?
Good question.
Or
Right now there is only support for horizontal and newly vertical planes perpendicular to gravity. So I don't think there is such a...
Always 90 degrees?
Yes.
Okay.
So I guess the reason for your experiment was to maybe build a feature into your IMO app for users to measure their apartment or stuff like that. Are you planning to release that anytime soon, or you think it's not?
That's a very good question.
Not good enough.
That's in the hands of the PM and the design team right now. So our job was to prove the viability of such a solution, like how mature are these tools. And I think our conclusion was definitive, that it is good enough to provide a working solution. Like in our experiments, it was at least as good as what you would get if you went knee on the floor, measuring tape through the room. And that's already a big improvement in the experience of the user. Now it's a matter of how does it fit with the roadmap of the product. That's a whole new story. We don't know yet.
Thank you. Thinking on the users, I have an iPhone X and I do metal stuff and SyncKit stuff, and it works. but it's an iPhone X. It's a beast. If you go to an iPhone 7, 6, is it going to be a good experience as well with this whole bunch of things that the app has to do?
Yeah, I really don't have experience with heavy apps. Like the demo you just saw was on an iPhone 7 Plus.
Okay.
You saw it lagging, but that's because of the mirroring. But on the phone, it's seamless. It really works.
Okay.
But of course, it's just one polygon, so I don't know for sure.
Another question. Did you have the chance to compare it to the deprecated Project Tango?
So Tango is for Android, I believe,
Yeah.
right? No. Sorry.
So fantastic presentation. Thank you so much.
Thank you.
I was just wondering, is other like extensions which can do object recognition, like face recognition or?
Face recognition is a good one because that's now available with the iPhone 10.
Yeah.
And I was pleasantly surprised when I was looking into it that it's actually just an AR session, and ARKit is giving you a higher level feature, which is face. So in the
Okay.
same way that ARKit recognizes through the rear camera a plane, a floor,
Right.
it can recognize through a front-facing camera a face. And it looks like pretty simple to work with that object because it's already filled with points that describe the smiliness of the face, or the different gestures. It's just all encoded into the anchor, face anchor that you get from the framework.
So you could basically do a Snapchat app or like face distortions quite easily then probably with that.
Yeah, totally. It's new possibilities. Of course, with faces, probably the tricky bit is the privacy aspect, and Apple didn't have that sorted out from the beginning. So, and then halfway through it, they decided, now every app using the front-facing camera of the iPhone 10 needs to have a privacy disclosure
Right.
that they don't use that face to create advertising profiles and things like that.
But Google do it anyway, right?
Asking for rating when you smile.
Exactly.
So are there any more questions or? Well, then a big round of applause. Oh, sorry. Sorry.
That's fine. Go ahead.
Go ahead.
How difficult would be to put this on some VR goggles for mobile phones, like make it a stereo, so to speak? Is it ARKit coming with any facility for that, or you would have to program it yourself?
I don't know about that, but I think Apple is preparing us all for the glasses or whatever it is going to be, and this is just the playground for us to get used to this new way of thinking, because it does take a little bit to get your head around this thing, thinking in 3D and thinking about your UI. So I think it's very smart the way they are doing it, that they're letting us getting comfortable, or at least not so awkward with these technologies. And when the new devices are ready, then I expect that they will be still programmed in Swift and with ARKit.
Maybe you find something with Unity 3D, and they have some ARKit plugins, and they have also virtual reality stuff there. I think at the moment this is the easiest way to implement something in this direction.
So, as I was saying, thank you very much, gentlemen. I think a big round of applause for a great presentation. I think we've all learned something. So, just to finish up, the next presentation will be on the 23rd of May, unless someone here wants to speak beforehand. We're always open to new speakers. We've got a great location here. We've got a sponsorship from Swisscom now, so basically, if you want to speak about something and you think it's valid for the community, please sit up. Otherwise, on the 23rd of May, am I saying the way there? Sorry. And it's going to be Philip Ackermann. He's actually done some pretty interesting stuff with augmented reality and creating VR kind of worlds from it. So he'll be giving examples of the app he's developed and code which actually did that. So we're looking forward to seeing you there. And if there's no more questions or feedback, I think it's time to get drunk. So thank you very much, everybody.